So there's going to be an x when we're solving equations. So we're solving equations using radicals. Part of what we talked about on Monday or Tuesday was fractional exponents, and so you can solve these with fractional exponents. But we're just going to, instead of using fraction exponents, we're just going to use roots. So radicals. Okay, so we're going to solve an equation. And the key here, as always with solving equations, is going to be our order of operations. Okay, you've seen this before, right? So either PEMDAS or GEMS, if I could spell. And so we have grouping symbols, exponents, though the spot that we're going to be focusing on is right here. This is where our radical happens, because technically, right, it's a fractional exponent, like x to the 1/5, right? So we're raising it to a fraction. It's not going to be a complex fraction, but we're going to write that exponent as a radical. So radicals are exponents. They happen at the same time because they're fractional exponents. Right, a fraction exponent. Okay, and we're going to work up the order of operations. We're doing inverse operations, and so we're doing the inverse of the order here, right? We're not simplifying, we're solving, and so we do inverse operations to solve. So if we wanted to, can we fit that on the screen? Nope. Here. Okay, and remember, you may need to pin the video if you want to see the whole thing. So we're doing order of operations. The normal order to simplify an equation, like if we have x and all the stuff, all the numbers on the one side of the equal sign, would be we would simplify any grouping symbols, we would do the exponents, then we would multiply and divide at the same time, and then we would add and subtract. These two happen together, they're the same as this step, and these two happen together, they're the same as that step. Right? So that would be to simplify. So we go down the order of operations. We're not simplifying, we're going to be solving. So x is going to be in the mix of our numbers. Okay, the kid has all the markers there, that's fine. I didn't see that till just now. It's going to be in the mix, right? So you have like 5x to the 5th or something. And so to isolate that variable, we're going to do inverse operations. So we're going to go the opposite direction, and we're going to do the opposite thing at every step. Right? You've been doing this since 8th grade, 7th grade. Inverse of addition and subtraction, inverse of multiplication, division, inverse of the exponent, and then we start over if there's parentheses, right? So we can cycle back to the beginning until the variable is by itself. And we want to isolate the variable. I need to zoom out. Whoa, not that far. Is that better, maybe? All right. So, for example, what is this going to look like? I'm going to write the problem out in its entirety for this one and then not for the other ones, right? So on the test or on a quiz or something, it would have this verbiage, but not every problem we will do, I'm going to write out all the words, right? So we're going to find the real solutions of whatever our equation is. And in this case, it's going to be 4x to the fifth equals 128. So, right, our variable is in the mix with the numbers here, and it equals some other numbers so that we can solve. That number could be like a lot of things, right? It could be 0, it could be whatever. Right, we can have zeros in our equations. So find the real solutions. Most of these are going to be like do one inverse operation step and then do the radical. I'm not saying that will always be the case, but usually we're going to be doing like two-step equations, so you only need to do like one or two of these things and then do a radical, or do a radical and then do one or two of these things to get the variable by itself. Paulina, did I zoom out far enough? And I will, Susan, I will upload it. This is going to go on YouTube. Or do you need me to zoom out? Oh, okay, good. Yeah. I don't want to zoom out too far because then, right, the text gets tiny. And if it's as large as the text, it's easier just to read on a blurry screen. So, we have our equation. And we're going to do inverse operations. So if we're looking at, I'm going to write PEMDAS on the side here. Probably won't need all that. We have multiplication happening. All right, so first we want to identify what operations are existing in our equation. Well, we have multiplication, we have an exponent. Those are the two things happening. So to get x by itself, we're going to do the inverse, and we're going to work up this way. So we're going to do the inverse of multiplication first, which is division, and then we're going to do the inverse of the exponent. And so I'm just going to pick another color, and we're going to divide to get x by itself. So x to the fifth equals, I don't know, actually I can do that in my head, 32. Right, 12 divided by 4 is a 3, 8 divided by 4 is a 2, 32. So I did this multiplication step. Now, how do we get rid of the exponent, right? It's x to the fifth. Well, on our previous lesson, we used radicals to get rid of the exponents. And we did the same thing back a chapter when we were solving quadratic functions if there was only like x squared in the equation and not some sort of b value. So it was like ax squared plus c equals 0, right? We would do we could do our inverse operations to get x by itself by taking a square root. Well, in this case, it's not just x squared, it's x to the fifth. So we're going to do a fifth root. Right, so the fifth root of x to the fifth equals the fifth root of 32. If we do the same operation on both sides, it doesn't change the value of the equation. I actually got to zoom in because this should all fit. Okay, so our exponent step is in black. And so we did the inverse of the exponents. Now we just need to simplify it. So the fifth root of x to the fifth, well, that is just x equals the fifth root of 32, 5 numbers that multiply to make 32. We can do this by hand. We can use a calculator. But we're doing fifth root of 32. We could do our factor tree. Numbers that multiply to make 32. To 16. 16 is a 4 and a 4, which is 2, 2, 2, 2. So I have 1, 1, 2, 3, 4, 5 2s, right? Because these numbers stop mattering. And so 5 2s is 5 numbers that multiply to make 32. So x is just 2. This is odd, so there's not a plus or minus. Right, this 5 is odd. So we could not use a negative 2 here to multiply to make 32, because if 2 is negative, we would get negative 32, because there's an odd number of factors. And so we're done. Okay. So this is like what we've been doing, what you have been doing in algebra for a long time. It's just adding a new toolbox, a new tool to the toolbox, right? We're adding in the fact that we can take higher order roots to solve for our variable. Okay? Any questions about that one before I move to do another example? Thanks, Paul. Alright, so for this one, I'm not going to write out all the find the real solutions. Right? Sometimes there will be more than one solution. Like for this one, there will actually be 2 solutions. So we're going to do x minus 3 to the 4th equals 21. And so we want to solve for x. This is going to happen where it does not fully simplify. That's okay. So I'm going to write PIMBOS to the side. You do not need to do this every time. But we're going to first identify the operations that are happening in the equation so that I know which ones I need to do the inverse of. Okay? We have an exponent. So we need to do the inverse of the exponent. So we're going to do this. This is actually going to happen first because it's on the parentheses and this is inside the parentheses. We're not going to add 3 to both sides and then take the 4th root. We're going to take the 4th root first because that's the most outside operation. So exponent happens first, and then we have subtraction. So we're going to do the inverse of that one. So we're still going to go up this PEMDAS thing, except we're looking at the outside. Outside of the parentheses, there is not addition, subtraction, multiplication, or division. There's just the exponent. So we're doing this first, and then we're starting over at the bottom of the order of operations and going up again. You really, if you don't need to write this down, don't write this down. Right? This is just to keep track of our operations. It's not required. Right? So if you want to just jump straight into, this equation, I need to do the 4th root of x minus 3 to the 4th equals the 4th root of 21. Okay, and then we would simplify that. Right? So the 4th root of a 4 exponent, an exponent that has a 4 in it, is just going to be x minus 3. Don't even need the parentheses, really. Now, we have an even exponent, or even radical here. So that means this number could be positive or negative, because an even number of negative numbers are going to multiply to make a positive number. So this is going to turn into a plus or minus, and here's the thing about 21. It does not simplify. We cannot simplify this radical, right? 21 is, that's a 27, that's silly. 21 is 3 times 7. These are prime numbers. And so you can put this into a calculator and get a number, because that number does exist as a decimal. We could write it as a decimal. But it's going to go on forever. Right? It's going to go on forever. So we're never going to get to the end of this number. And so instead of rounding and losing a bunch of information, we just leave it like this. This is the 4th root 21. Plus or minus because it's even. So then, now, we start over our order of operations. We go back to the bottom, and we say, oh, okay, now I have subtraction, and we need to do the inverse of that. So there's a 3 here. I'm going to add 3 to both sides. And so x is going to equal... Now, this 3 does not have a root. So we're not going to combine these numbers. We're not going to get the 4th root of 24. No. It's just going to go in front of the plus or minus. This is like when we had complex numbers with an I, imaginary number. There's not an imaginary number in this problem, but it's going to look like one. It's going to have a plus or minus in the middle. So 3 plus or minus the 4th root of 21. Now, on a test or a quiz, I will be content with this as the final answer. But you can put it into a calculator. Okay? I don't like decimal answers because they're not the most accurate thing. But we want to use our calculator to find the if we want to find the value, which is going to be more important when we're doing like exponential functions and thinking about real world problems with like money and stuff. We've got to know how many dollars it's actually going to be, right? This isn't in dollars or anything. But if we wanted to know the value, this is going to be 2 different values. We're going to go to the right of 3 a little bit and to the left of 3 a little bit. And so we can plug this into a calculator and we'll get 2 different values. So I'm going to actually go to Desmos and do this. If I can find it. Yep. Okay. And then this thing. Whoa. That's cool. All right. So we had 3 plus the 4th root This is the square root of 21. Do I put 4 there? How do I do? No, I don't actually know. How do we put a 4 in there? Well, I do know how, but not in the... Oh, here it is. If you go to miscellaneous, you can then type the 4 up there. The other way to do this, if you cannot find the function and then miscellaneous button to do the nth root, would be to do 3 plus 21 raised to the quarter power. Right? That's the same thing. So, we get 5.1 going on forever. For one of our values, that's one of our values. The other value is if we would have subtracted this. So if I copy and paste, change this to subtraction, then we get 0.85 going on. So x is 2 numbers. 5.14, and we write ... because it's not 5.14, it's information after this, and then 0.85 also going on. We're not rounding, so I'm not going to change that to 0.86, even though there's a 9 next. We're just saying there's more information that comes afterwards. Okay? And yeah, those are our 2 values. So when we have even roots, it's possible that we get positive and negative numbers. Okay. Now it ends up that this is not actually 0.85 does not turn into, this is not a negative number, but it's less than 3, right? So we have a number that's bigger than 3, we have a number that's smaller than 3. Sometimes these could both be negative. Not true. Possibly, depending on what this 3 looks like. If that 3 is If this is plus instead and we subtracted, yeah, both negative. So it kind of depends on where these inverse operations are happening in the problem. Okay? And I think that's all the examples I want to do. Is it? Yeah, it is. Oh, no, it's not. Let's do this one. If I copy and paste this, we'll just paste it in the chat. Close. Alright. Let's not waste any paper. Where did I say the problem was? X plus 2 cubed. X minus 2 cubed equals negative 14. So, and we talked about this in our last lesson a little bit, but we have a negative number, and we're going to take a root of a negative, but because this is an odd exponent, that's okay. So, same strategy. We're going to do inverse operations. We're going to go this way. We have subtraction, and we have an exponent. And as with the last problem, the subtraction is inside the exponent, and so we're going to do the radical first, and then we're going to do the inverse operation for the exponent. So we have the cube root of x minus 2 cubed. So the cube root and the cube cancel out. And then this is equal to the cube root of negative 14. Because this is odd, we don't need a plus or minus. And this is negative, and that's okay. This is actually the same as negative cube root of 14. Doesn't matter, we're not going to write it that way. X minus 2 equals the cube root of negative 14. So then we do our last inverse operation, which is to add 2 to both sides. And this is positive here. I mean, it simplifies to a negative, but it's positive here. So we get x equals 2 plus cube root of negative 14. And in the same way, we could plug this into our calculator on Desmos, and we would get 2 values for x. We want to save our calculator to the very, very end if we're going to turn it into a decimal. All right, so this is a perfectly acceptable answer. This is it. But if we're going to go plug that into a calculator, we want to save the calculation till the very end. If we had a bunch of roots here for some reason, we want that calculator to do the work all at the same time, so it doesn't round as much as possible, right? If we're this problem doesn't have a lot of calculations in it, but if we do like a calculation here, change this to a decimal, and then there was another one, and we changed that to a decimal, and then another decimal change. If we round every time, we've actually lost a lot of information. So we want to save our calculator to the very end of the problem. I hope your other classes that have you do math are telling you to do that too. Okay, so then I would go to Desmos. This is not Desmos. Back to Desmos. And then we just need to change these numbers to what we had in the problem. So this was let's get rid of that. This is a 2. This was a cube root, and it was negative 14. 2 cube root, negative 14. And this should actually be not minus, but plus. I don't know why I did that twice, because there's no plus or minus. So it's just this one value. We'll head to 2. Okay, so from our calculator, we get negative 4, 1, and then we do dot, 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 meaning there's more information after this. I'm just not going to take the time to write it down. Okay? So there's only one value. This ends up being a negative number because the cube root of 14 is bigger than 2, and this is negative, so this turns into a negative. This whole thing is subtraction. So it's 2 minus a larger number, and so we get a very tiny number, but it's negative. Okay? So either of these are acceptable answers. Either. In fact, on the test, I'm going to prefer that you leave it like this. You don't need to change it to a decimal. Just leave it like that. Okay? So now we're going to go practice on your